We will show using Moduleworks swarf machining functions to make toolpaths. We will output the toolpaths to a waterjet machine with 6 degrees of freedom. All 6 axes can run simultaneously, so the output is quite complex. We will simulate the machine and see the nozzle trajectory realized on the actual kinematic system. First, we will import a 3D model of the target part by an IGS file. Position the part to the right position. Its center line must pass through the origin and along the positive x-axis. This is because the divisor axis is along the machine x-axis. Open Moduleworks add-on for advanced machining functions. Select tool diameter as 1 mm to represent the waterjet. Open the Swarf Machining tab. Select Swarf surfaces and let the system calculate a toolpath. We will change it as needed after we see the result. We can swap the toolpath direction. The result makes sense after swapping the directions, but there are problems again. We need to retract the nozzle so it will not plunge into the uncut cylinder material. We will use the collision detection and handling page. In this tab, we can introduce 3D models to avoid colliding. The toolpaths will be modified where there are collisions between the tool and the check surfaces. The system will retract the tool along its axis direction and make it safe. We will output our toolpath by a post-processor capable of handling 6-axis degrees of freedom. It will ask the user for each operation whether to use the divisor at a fixed B angle or rotate the divisor simultaneously during this particular operation. Once we want to print the G-code, a pop-up window will appear. We will prefer simultaneous rotation instead of a fixed B angle for the first operation. We will use fixed divisor for the last cutoff operation. To simulate this cutting process, we should load our machine. This is possible by Insert, make Transformation Group menu path. We will attach the part model to the divisor of the virtual machine. Select the surfaces to attach and create a group link on our tree view. Select the appropriate models and right-click on the graphics window. Give the command group, Insert Tree Link. Give a name to the selection group, for example, part. It will appear on the tree view. Your virtual machine kinematic tree rests under the Tree View V-Transformation Group node. Expand it to reach the Part Holder B node of this particular machine model. Right-click on this node and give the command Add Part by link name. This will attach the part model to the divisor model, and an increment of B angle will rotate the part together with the divisor model. We will load the simulation file on the control panel page. Right-click on any node of your V-Transformation Group and give the menu command Control Panel. Select the process file printed by the post-processor using the Read button. You can run the simulation step by step for each line on the control panel page.